So now that we know how to evaluate trig functions of any angle using these new definitions, let's talk about some relationships about our trig functions and the quadrants that they lie in. In some cases, we will not be told explicitly what quadrant an angle is in, but we might just have enough information to figure it out. So let's take a look. The signs SIGNS, that means positive or negative, of the trigonometric functions in the four quadrants can be determined from the definitions of the functions. In the first quadrant, sine, cosine, tangent, and each one of their reciprocals is always going to be positive. The reason being is because the x and the y coordinates are all positive in the first quadrant. Notice that in these definitions, sine, that's y. Well, y has to be positive. R is always positive. Remember that R is a distance. It refers to the radius of the arc, always positive. A positive over a positive gives us a positive. Same thing with cosine. X must be positive in the first quadrant, divided by R, which is positive, gives us another positive. A positive Y divided by a positive X in the first quadrant, that is going to give us a positive value for tangent. As we move into the second quadrant, the x coordinates all become negative. That means that sine is going to be positive. That corresponds to y divided by r. Cosine is negative, x over r. And tangent is also going to be negative, y divided by x. The reason being, if I take a positive and divide by a negative, I get a negative. Notice that each one of their reciprocals also follows the same pattern. Cosecant is going to be positive, secant is going to be negative, and cotangent is going to be negative as well. As we move into the third quadrant, both the x and the y coordinates are negative. What this means is that sine is going to be negative, cosine is going to be negative, and tangent is going to be positive. Notice that tangent becomes positive because I'm taking a negative and dividing by a negative. Similarly, each one of their reciprocals follows the same pattern. Cosecant of theta, the reciprocal of sine, will also be negative. Secant of theta, the reciprocal of cosine, is also negative. Cotangent of theta, the reciprocal of tangent, is positive. And as we move into the fourth quadrant, where all of our x coordinates are positive and our y coordinates are negative, that means that sine is going to be negative, cosine is going to be positive, and tangent of theta is going to be negative. And again, their reciprocals follow the exact same manner. Cosecant is negative, secant is positive, cotangent is going to be negative. All right, so this gives us a piece of information that we might not have already known. Okay, and hopefully it makes sense based off of our x and y coordinates on our coordinate plane. How are you guys going to remember this? Well, here's the easy acronym. All star trig class. All right, that's you guys. In the first quadrant, all of our trig functions are positive. For angles that are in the second quadrant, star starts with the letter S. Notice that sine is positive as well as its reciprocal. As we move into the third quadrant, T, tangent is positive as well as its reciprocal. And as we move into the fourth quadrant, C, cosine is positive and its reciprocal is positive as well. So A, S, T, C. All-star trig class. That will allow you to remember which ones are positive in which quadrant. So let's put this to use now. Given that tangent of theta is equal to negative 5 over 4 and cosine of theta is greater than 0, find the exact values of the remaining trigonometric functions of theta. So we always want to start off by drawing out our angle in standard position. Now, one thing is, we're not told which quadrant this angle is in. Not explicitly anyhow. But take a look at these values. We know that tangent is negative, and we also know that cosine of the angle theta is positive. That's what it means to be greater than 0. So, if tangent is negative and cosine is positive, which quadrant must theta be in? Well, tangent is negative. This would be tangent is negative in quadrants 2 and quadrant 4. and cosine is positive in quadrant 1 and quadrant 4, if both of those need to be true, then our angle must be in quadrant 4. So we can draw our angle now. Here we have our coordinate plane. We know that we have an angle that's going to be in quadrant 4. We draw on an angle. We label it theta. Now, let's see if we can get a little bit more information about this angle. We are told that the tangent of this angle is -5/4, and we know that the definition for tangent is y/x. Okay, well, y divided by x. Notice that the y-coordinate is going to be the one that has to be negative here, all right? And the x-coordinate has to be positive. Well, to make this 5/4, we can just make x +4 and y -5. That means I go to the right 4 units, down 5 units from the origin, all right? And now we have our angle theta. We have x and y. This would be our ordered pair x comma y. That would be 4 comma -5. And if we're going to evaluate the trig definitions of our angle theta, then we must know r. And we can find r using the Pythagorean theorem. We know that r is equal to the square root of x squared plus y squared. So r is equal to the square root of 4 squared plus -5 squared. 4 squared is 16. -5 squared is 25. That's the square root of 16 plus 25, which gives us the square root of 41. And once we have our point x comma y and we have r, we can evaluate our 6 different trigonometric functions of theta. The sine of theta. Sine of theta, our definition, y divided by r. That's going to be -5/√41, which we can then rationalize, and we get our final answer, -5√41/41. Cosine theta, our definition for finding cosine is x divided by r. That's going to be 4 divided by √41, or 4√41 divided by 41. Again, rationalize those denominators. Tangent of theta. To evaluate tangent of theta, we take y and we divide by x. That would be -5 divided by 4. And again, good thing is that that matches out with the given information that we were told. Cosecant. Remember, cosecant is the reciprocal of sine. That's r divided by y. √41 divided by -5. Secant is the reciprocal of cosine. R divided by x. That's √41 divided by 4. And tangent, cotangent, which is the reciprocal of tangent, is x divided by y, leaving us with -4/5 for our answer. All right, let's try one more. Given that secant theta is -7/3 and tangent theta is less than 0, find the exact values of the remaining trigonometric functions of theta. Well, secant is negative. Secant is the reciprocal of cosine, which means that the x-coordinate must be negative. Well, what quadrants is that? That would be quadrant 2 and quadrant 3. We are also told that the tangent of theta has to be negative. In which quadrants is tangent negative? That would be quadrant 2 and quadrant 4. Well, if both of these have to be true, this means that our angle must be in quadrant 2. All right, so when in doubt, draw it out. Always good to draw a picture. Here's our coordinate plane. Let's draw our angle in standard position. Again, your pictures don't have to be drawn perfectly to scale. All right, here I have an angle that is in the second quadrant. And again, notice we always start in the positive x-axis. What else do we know about this angle? We are told that secant of theta is equal to -7/3. Well, think about our definition for secant theta. Secant theta is r divided by x. We know r always has to be a positive value. R is a distance. It is the radius of the arc. And the x-coordinate, because we're in quadrant 2, has to be negative. What does that tell us? Well, here I have r as being +7, and I have gone 3 units to the left. Notice that we can generate a right triangle. And why is that going to help us? Well, in order to evaluate our 6 trigonometric functions, we also have to know why. What's our relationship? Via the Pythagorean theorem, well, we know that r is equal to the square root of x squared plus y squared. Or 7 is equal to the square root of negative 3 squared plus y squared. If I square both sides of the equation, I get 49 is equal to 9 plus y squared. And again, you can get that straight from the Pythagorean theorem, right? Negative 3 squared plus y squared has to equal r squared. And subtract 9 from both sides, we get y is equal to the square root of 40, which we can then simplify into 2 root 10. Notice that 40 is 4 times 10. The square root of 4 is 2. And once we have x, y, and r, we can evaluate our 6 trigonometric functions of our angle theta. All right, and again, here it would be our ordered pair. We've gone negative 3 units along the x-axis, and we've gone 2 root 10 units along the y-axis. To evaluate the sine of theta, we take the y-coordinate and divide by r. 2 root 10 divided by 7. To evaluate cosine of theta, we take the x-coordinate and we divide by r. Negative 3 divided by 7. To evaluate tangent of theta, we take the y-coordinate and divide by the x-coordinate. Negative 2 root 10 divided by 3. Cosecant, this is the reciprocal of sine, r over y. That gives us 7 over 2 root 10, which we can then rationalize by multiplying by root 10 over root 10. This gives us 7 root 10 over 20. Secant theta, the reciprocal of cosine, r divided by x. That's going to give us negative 7 over 3. And cotangent of theta, the reciprocal of tangent, that's x over y, that is going to give us negative 3 over 2 root 10, which we can then rationalize any radicals and denominators by multiplying by root 10 over root 10. We get negative 3 root 10 divided by 20. All right, so there's how we can use the information of which quadrants have positive or negative trig functions to help us in evaluating trig functions of any angle.